All right, good evening. So I think assignment 3 delivered, graded, 4 on the way. Now looking to prepare for number 5 today. So as always, I'm going to start off with a review of what we did last time. We're going to do a review of what we did last time, okay? And the goal is to prepare you for assignment 5, which means going through file IO exception handling tonight. And then next time we're going to start talking about abstract classes, and interfaces. So you guys can work on assignment 6. Yeah. Creating APIs. Now somebody emailed me and said, we have not covered the material for discussions 8, 9, and 10. So what I found very constructive though was that people have already responded to these discussions, which is nice. But I went ahead and set the due date for those to August 4th. So more participation can happen. So we have 3 more days to go. I mean, 6 hours of lecture, and your final is on the 4th. It has been a very quick, short quarter. So. But it was nice to see that because there was a due date, you self-studied and reported some response for those discussion questions. That was very good. So the discussion is extra credit, yes. So let's get started. So I covered inheritance, polymorphism, and packages last time that you're applying in lab 4. Surprisingly, not a lot of questions for assignment 4. Assignment 3 was, kept me busy, but 4, I don't know. Maybe it's easy assignment. So when we talk about polymorphism, there are 2 facets of polymorphism. We have overloading constructors and methods, right? And you guys do realize the definition of overloading, of polymorphism, right? One word, many meanings. So that is achieved in 2 ways. One is with overloading, and the other is with overriding. Overloading happens with constructors or methods in the same class. Overriding happens with inheritance. Same signature of method across classes. And please have some fun with this. Because you cannot override static methods. There's some funny behavior with these, so please play with it so you can answer some questions on the final. And overriding a constructor is not possible. You should know why. Overriding of methods is for making self-contained classes. In a well-defined class definition, a class will have its own responsibility. Nature is very good at this. Nature makes everything self-contained. So let's learn from that and make our classes self-contained. This is also a good exam question. What is the meaning of being self-contained? So when I look at my object definition, my class definition, I have everything that a class object would need for it to exist. Okay? So if you think of the water heater has all the properties and methods that and behavior. So it can heat the water. But by next week, you will also understand all the interfaces that have to be built with a water heater. So it can be installed with, connection to a gas and electric and other, water input, water output. So cold water comes in, hot water comes out, vents, all those things. So those are all the interfaces that will be defined for the water heater. Is the notion of self-contained clear to everyone? Can everyone respond in the room? You can always use that little checkbox that Ananya used, if you can find it, that is. And if you're not listening or you don't care, I understand. Sorry, sending a little guilt trip there. Is it working? Only with 4 people. That's how online learning works, right? Okay. So you have to understand the concept of dynamic binding as well. Dynamic binding. There were 2 parts of this that I covered. Yeah, there were 2 parts that I covered. Loading classes. And we basically load a skeleton in memory. Bytecodes for methods are not loaded. And then what happens is, another extension of that is loading the bytecodes on demand. When we talk about inheritance and polymorphism, we have, say, a shape class, and we have a square class. Square is a child of shape. So you can certainly create a object. We can create an instance of child by using square reference. We can also create a shape by using a shape reference. When I say reference, I mean, like if I say shape A2, then A2, this is a typo. A2 is the name of the object reference or name of the object. Or just like your name, right, is your object reference. So Bob Singh, Bob is the name of the reference. An object is the actual 200 pounds sitting on some chair somewhere. It doesn't matter where. So when I say new square or new human or whatever, that's the actual object that lives on the heap. So running the object is its class definition. That's where dynamic binding comes in. Okay. So the shape class is loaded and square class is loaded moment that statement is executed. And when we say a2.sum method or area method, we go out and look at the type of the object, people. We look at the type of the object, not the reference. We look at the type of the object and load that object in memory. So when you end up with shape and square class, which I'm not going to cover again, but I built an array. This is how I get polymorphism. How is that? I've got instances of shape and square. Is this clear to everyone? How instances of parent and child can be assigned to shape? Shape array, I mean, like this. 4 lines are clear. Use that checkbox, people. Yes, no, it works out really well. Please, let's interact. All right. Is there an area method in shape class? There is. For it to be overridden, you have to define it in parent. Overriding means same signature in parent and child. So now, when we call the area method in a loop, right, we've got overriding. So there's dynamic binding happening. There's dynamic binding happening. When we go with 0, we call the parents method. Why? Because shape is of type parent, you see. Here we call the method of type child. We call the square method, we call the area method in child. All right. So this is polymorphism, dynamic binding, enabled with dynamic binding. This is what makes Java a thin client programming language. So now we make an object of type shape. Shape is of type parent. When we call area, it calls the area method in parent. So if we just make an object of type square, it's going to call area and print in square. Area and print is in the child class. That's what these 2 lines will call. How does overriding help? One word, many meanings. Polymorphism, just like every natural language, has polymorphic words, right? In language also, we can program it so it means different things for the same word. And to me, this teaches me what is evolution and how it evolved over time. So can you guys comment on that? Does that make sense to you as well? Do you actually understand how evolution was implemented in nature as a result of understanding inheritance and polymorphism in this class? Comment on this. No, yes, no. But so here is actually I'll give you an extra credit question. You guys like extra credit, right? So do this for me. How does understanding inheritance and polymorphism gears or helps with understanding of evolution. A 1% increment to your grade for answering this question over voice in the classroom right now. And of course, if you get it right. Anybody want to take a shot? And if you send an email to my personal email address, the credit goes to it won't be 1% increment, but it'll be 0.25% increment. So you still get something. But this is to encourage to talk about this in class. I'll be quiet for a minute so somebody can talk about this.
Can I give it a shot?
Heck yeah. Why not?
So to my understanding, inheritance basically allows child classes to extend the functionality of parent classes. And in nature, it represents evolution because over time you have different classes that have similar features as to previous generations, but they've also expanded on them and developed new ways and new abilities to create it ties in with polymorphism because you have something like sound, and over time with evolution, sound has come to mean different things for different animals, and that is a result of evolution and adapting to whatever is needed in their environment.
Beautiful, Ananya. Well said.
Thank you.
Now make sure I update this by 1%. I should deliver what I promise, right? Very nice. Spot on. So when we get mutations, that's polymorphism. So in software design, you can use evolution, or what we may call Darwinism, to exhibit this. So this is definitely one area that Ananya established. There are many more. So I look forward to written responses as well. But the core of polymorphism is overriding methods, modification of previous generation behavior. And that represents evolution. So whether in whatever form factor you may have studied this or will study, in case you end up studying, right? So very nicely done. Anything else to add from anyone else by voice? New thing.
I have a question.
Okay.
Well, how is inheritance and polymorphism used differently in the explanation for evolution?
Inheritance is passing of. So inheritance and say if you were talking the world of, if you were to talk about in the world of biology, is using genes from parents to provide the color of your eyes, color of your skin, color of your hair, etc. That's inheritance. In the world of genetics, that's also called gene expression. Gene expression simply means how the codons in genetic code, or how do the genes as a group, to keep it in non-technical words, expresses or shows itself. So a gene that will have black color hair or blonde color hair, will show itself. It's passed from parent to child and shows itself. And that would be inheritance. Now, the thing is, if I answer this question, then if I see these ideas written back, I'm not going to give credit for whatever question I'm answering, right? So polymorphism is a gene that has black color hair and providing variations of those colors, perhaps in different ethnicities. So you might see black color hair that are, I mean, different shades of black color hair that you might see. So that would be polymorphism. And did I answer your question?
Oh, yes.
Okay.
Thank you.
So that was the very question I asked you. So thank you for having me answer my own question. Yeah, Shivani. Go ahead.
I just wanted to add something on to Ananya's answer, which was really good. Just one more thing about inheritance and polymorphism in relation to evolution would be how inheritance and polymorphism in our code is used to help with reusability and efficiency of our code. And that is directly correlating to evolution, how evolution is used in biology and throughout history, with it happening, is used to make it easier for humanity in like reusing those genes and showing up in like children from different generations. I think that's just another one that shows up between inheritance, polymorphism, and the other.
Very, very nicely put.
Thank you.
So reusability is a key. So nature is smart about reusability. How so? Well, as Shivani presented, so there is, I mean, there are genes for every physical attribute. So it is also likely, and this is where a geneticist can probably talk better than I could ever, but the sequence of the genes, and first of all, the basic nucleic acids that are used are probably common across a set of species. So that talks about reusability. And then when you end up sequencing the genes, and you have learned the names of the genes, at least in lab 2, right? There are, and then the concept of DNA and RNA. So how the genes are sequenced, those sequences are also important because a sequence may represent a feature of a person, whether it's height or color of hair, color of skin, color of eyes, the length of your head over the shoulders. They're all kind of different, different aspects. And so at the class definition level, those properties are extended. So they're only defined once, as you can see in a parent-child relationship. They're only defined once. But then when that class is extended, the parent class, the child class gets those properties. So definitely a notion of reusability added. So I think Animesh, please go ahead.
Yeah. Wait, can you hear me?
Yes, please go ahead.
Yeah. So this was kind of already mentioned in the previous people, but if like, for example, if a piece of code is reusable, then it's usually very optimal. And for example, in evolution, if you take a look at like bears and the bears that migrated to icy areas through polymorphism, one of them had a genetic mutation to have white fur instead of the regular brown. And because that one had better chances of survival, because that one had better chances of survival through inheritance, that bear was the one that reproduced more, and like it spread to all the other animals.
Right. You reminded me of a field trip I took in my high school. But very nicely said. You're talking about how a property exhibits itself. So in case of algae or algae, depending on how you pronounce it, it all, you know. I took a field trip for my, you know, what would be compared to AP biology back in high school. And my teacher, she made us measure rock pools. This was in UK. So we went to Wales, and on a very kind of rainy day, we went to the beach and there were a bunch of rock pools. Rock pools have fresh water by the seashore because of the rain, right? And if the waves get the water far high enough, then the water can fall into the, salty water can fall into the rock pools. But she was trying to teach us polymorphism. And she had us measure the color of, I mean, I'm colorblind, so I needed some help, but there's like when the water falls on the surface of the, when the water falls on the surface, like at the, you know, it kind of, or did I say water? When the light falls on the surface of the water in the rock pool, it actually creates a spectrum, 7 colors of the rainbow. And when the algae is subjected to those 7 colors, it changes its color. So that's why you get algae in, you know, all the different colors of the rainbow, violet, indigo, etc. You probably know this acronym. We were taught to remember the colors of the rainbow like this, and some of you may actually reverse that. And you may call it something like this. I remember Vibgyor as a word, yeah. So you can see the polymorphic effect is the color of the algae. Based on its environment, it tends to change. And Animesh, you went through the example which talks about that. So environmental effect on polymorphism is what Animesh took the discussion towards. So if you guys end up, we haven't talked about this at all in our starting point here, but if you were to use machine learning and you were to take the adaptability, you can make adaptive objects. So like you can have a face recognition, you know, a camera object that deals with face recognition. Now, polymorphic effect may be that you learn from images that are deployed using whatever camera, right? And if you were to have accuracy in identifying the face, that could be a polymorphic effect based on the environment. So these things are important to realize. While you're only understanding atoms here, when we talk about polymorphism, parent-child relationship, what the parent class can see, what the child class can see, and all that, the molecule construction is happening here. So how is overriding useful? So overriding is useful with one word, many meanings. So overriding is one method in the parent class. And overriding means taking that, excuse me, taking that same signature in the child class and writing that. And so when we call the area method here, we call the area method of parent or child because the signature is the same. Does that answer the question that last person asked? You know who you are. It was a private question, so yeah, I don't want to. Okay, good. So we also talked about packages, which was about code organization, and some people ask this question, how should I submit the assignment? Well, I'll launch Eclipse and show you, but you simply submit the source folder. So you go into properties. And you can just send me the source folder. Just copy and paste it, put it in a zip file and send it over, okay? So tonight we're going to start with file IO and then talk about assignment files. So let's do that. Unless somebody has any other questions, then I would welcome that. But I'm going to put this in my notes so I don't forget.
Professor?
So I don't, 1 second, please. So I don't forget the extra credit. Okay, yes, go ahead. Sorry, I'm not sure who that was, but please go ahead.
Well, I was wondering if it's too late to add to the discussion on the evolution.
Say that again?
Is it too late to add to the discussion on the inheritance and evolution?
Well, I've moved on from the topic, but yeah, if you have something to add, please go ahead.
Oh, I was thinking like thinking evolution over a duration of time and think of like every generation, like every class in the multi-level inheritance. Like if there's like several classes, like that's adjacent to each other, like inheriting from the one next to it. And like how like over time natural selection is able to pick out like traits of the previous generation and adapt to the environment.
Natural selection would be a very complex implementation in software engineering. So if you take the aspect of natural selection and talk about how it's implemented, that may need a little more explanation. So how would you go about that?
No, I was just talking about like just in a multi-level inheritance, like there would be like each class would represent a different generation of change in like an animal or like the group of animals.
I see. So you're talking about single versus multiple inheritance.
Yes.
But you also said something about natural selection.
I think I just used the term wrong. I was just thinking of like evolution in general, but I guess I just used the wrong term.
Well, natural selection can occur also because, especially in Java virtual machine, there is garbage collection. Kind of beyond the scope of this course, but the way the garbage collection works and how garbage collection moves objects from memory could be a notion of, could be an expression of natural selection. But yeah, I mean, inheritance was talked about by your three predecessors. I would ask you to submit a written, like an email for extra credit. Please do that, okay? All right, I'm gonna move on. So we talked about, we have to get into file IO today. So file IO, I mean, I'll add your name here, okay? And do you pronounce your name Doyoung? How do you say your name?
Do-hyung.
Doyoung, okay. So it's not, okay. Doyoung, okay, got it. Okay, yeah, but I definitely want to see your ideas in an email as well, okay, Doyoung, if you don't mind. So, all right, so to move along, file IO. There's a lot to be covered in file IO. So what I'm going to do is I'm going to do a two-part coverage. One, what you need for lab 5, and other what you need for in for the final. So in file IO, we need to look at Java's machine architecture one more time, at a high level, of course. So you have your hard drive where all the files live, okay? You may have a, I guess, one of those faster flash drives. But from our perspective, in Java, it doesn't matter what kind of hard drive. As long as you have a storage device is how we will put it. So now, within the operating system is a manager for the hard drive, or the operating system is the manager for all hardware. And within the operating system is something called a file system. That's simply a database of all files on the hard drive. Okay, it's a database of all files. So when you use Microsoft Word, Excel, PowerPoint, browser, etc., it's using the file system to get access to specific files. So you can just assume that the database is just like, it's got one row for each table. Okay? It's got one row for each table, yeah. For each file, I'm sorry. And so when Java Virtual Machine or Microsoft Word or any other application is programmed to access the file, it looks up the file system and says, does the file exist? If it does, then it'll open the file or for reading or writing. So there are different modes that the files work in. So in a Java program, what we do is we have to create a file object that takes in a file name. There's somewhat conversion with that because of lab 3. And we get this inside the JVM. So once we get the file, then when the file object is created, right, we can then do things with it. So what can we do? What can we do with the file object? What can we do with file object? We can open the file for reading and writing. And that can be for text or binary files. We can set up buffers to speed up reading and writing. Not only that, we can also create filters to manage data in the file. A lot of different things. So there are many different types of files. There's like 50 different types of file classes that are available in the Java API to manage the different aspects. So if I'm dealing with reading and writing text and binary files, there are all these different objects that I need you guys to learn, and with all these programs. So when we are dealing with text files, we have these classes. When we are dealing with binary files, we have these classes. And when we are dealing with filters, we're dealing with these files. So the interesting question would be, well, I don't understand all this. Like, what are you talking about? Well, so let's go through it slowly, right? So first thing, returning back to when a file object is created in a Java program, it sends so I want to open a file. It sends a request to the JVM. It looks up the operating system to see the file I want is there or not. If it's not, then it will throw a file not found exception. When it finds the file, if it finds the file, it won't throw a file not found exception, but it will send a non-null value, some hex value that apparently has the location of the file information inside the file system. So that's the first thing that happens. So the sequence of things we do when opening a file are these. And you have to understand this process. You create a file object, and then once the file object is created, we connect it with a stream. Stream is nothing but a sequence of bytes. Just like if you were to connect, in your chem labs, you've probably done this, or physics labs where you have two beakers and you connect those with a pipe. So pipe acts as a stream for the water to flow from one beaker to another. Same thing here. Stream is the pipe that transmits information from the file on the file system to the program in memory. And the streams can be of two types, binary or text. Binary streams are binary streams and text streams. Binary streams are just a sequence of zeros and ones, and there is no return character or carriage return line feed. It's the exact representation of memory. So it's hard to decipher binary data. Text data, however, is also in, it's sequence of zeros and ones. Only if I could type a zero today. Yeah, it's a sequence of zeros and ones translated into text. for the human eye to read. For the human to read, with support of all the natural languages today as well. So there's also a carriage return line feed. Does everyone know what CRLF means? It's like when you hit the return key on your keyboard. When you hit the return key on your keyboard. So, all right. So binary files are fast. And these files are slow. I'm obviously working with a text file here, where I'm typing my notes in this text editor. So. Actually, I could have just copied this for you guys, and that would have been good. And then you have to learn about buffers. Buffers are to speed things up. When you buffer things, like let's think about your, I love to talk about your bank balance. Your bank balance is a buffer. So you go out, work, get a paycheck, and the paycheck drops in your account. So your account becomes the buffer for paying the bills. So same way memory is used inside your Java program to read all the data from hard drive for processing. I mean, imagine if you have to pay a bill using streams. What would it be like to pay the phone bill using streams? Somebody might look at this question and say, it's a very idiotic question. But the metaphor is that if you have to pay a bill using streams, that means, let's say you have to pay $31.28. That means you'll have to make 3,128 or whatever I said, trips to the bank to get one penny out and then go do the payment. So when you write a check, it's a buffer, just to make the point. And then we have filters. Filters are about data conversion. So if you were to do text to binary conversion or binary to text conversion. And filters work with buffers as well. So if you have a text data, so we can use our calculator, programmer's calculator, right? So if I was to represent the number 11 in decimal as an integer, it takes up 4 bytes. As a character, it will take up 2 bytes. Actually, with the char data type, each char being 2 bytes will take up 4 bytes as well. But the binary representation of 11 is 1011. So if I take maybe say a number like 45, that takes up 2 characters. And here it takes up, in Java, it takes up 4 bytes. This is the difference between text and binary, and then the conversion that we have to do. So another example could be a very large number. Something like this. 4 million, or is it 41 million? So this is still taking 4 bytes only. okay? But here we would have 8 characters being used. Another interesting one, another interesting filter that I'm sure you're going to want to learn about is Google Translate. That's also a filter. Anybody used? I'm sure you have, right? So this is what I would love to have in the near future. Polymorphism. So I can have my lectures converted from English to Spanish. Or if somebody says, hey, you know, Bob, can you lecture in your own language? Or actually, that would be pretty cool. Me lecturing in Punjabi, which is what I speak. But let's say if you were to convert this to Mandarin, I would start with Chinese simplified. So, sorry, somebody was saying something. Please go ahead.
Oh no, I was just saying that you were converting from Spanish to English and not English to Spanish.
Well, it should have auto-recognized poor polymorphism on Google's part. But anyway, it was corrected. So thank you for that. Yeah, I saw that. So this is also polymorphism in the ecosystem. If I go around the room asking, hey guys, what's your preferred language to use? You know, in the Stone Age, we would say, well, everyone should know English. Why? Why can't everyone just know their language and let there be a system that does the translation? And so anybody that knows Mandarin, or I don't know if this is Cantonese or Mandarin, so please forgive me for that, but anybody that knows this language, can you accurately say, is this pretty good translation? Somebody can respond in the chat room for me, right? Right. So there are a couple of topics that are being covered here in parallel. Is there extra? No. You guys are extra credit hungry. You just don't want to like be of community service. So, okay. So the point is filters, okay? So it's not far away that, you know, maybe a few years from now, one of you might actually create this tool. And this week, you guys are going to learn how to use and create APIs. So you can use the Google Translate API to build your buffers. I mean, to build your filters, to do the language conversion. That's where I took the conversation. Language translation. And I'm also going to teach you guys another type of a filter that can archive an object. So you instantiate, well, I don't have any objects today, but from my notes from last time, right? If I could take an instance of cat and write that to disk, that process is archiving an object. It's called serialization. And they're called object streams. You use object streams to make that happen. So conceptually, how are we doing, everyone? What is the file? What are the different tiers for accessing the file? How is the file opened? When the file opens, what do we do with it? What are the different types of streams, buffers, and filters? Okay. So we talked about all that. So let's go to the core shell and download the programs associated with FileIO. Yeah, FileIO. When you click on that link, you're going to find this video. Play it, and this is the, I expect you guys to watch this because I'm only going to cover text files in this. I'm only going to cover text files today because that's what you need for your lab 5. The rest of the stuff, all this, you need that for your final, including serialization, object input stream and output stream. So please find about 30, well, it's 45 minutes, but you know, it covers the whole gamut that I just covered. Please find an hour to review and take notes. Using FileIO programs, you can yeah, so we have all the FileIO right here. Right. So let's start a command shell. Go to downloads. I mean, you can run these programs in what do you call Eclipse as well. Just has a higher setup cost, so I'm running it in a program shell. This is actually called the command shell. Basically, you have the entire operating system at your hand. Side comment, learn Unix. Take intro to Unix class, please. It's not that I get paid to say this to increase enrollments at the Anza. I mean, that's the side effect always. But the bigger side effect is, jokes aside, okay? The bigger side effect always is what? You need to know Unix. So there are 2 courses in this. So in your programming lifetime, you must take these classes. It's a skill that is expected in the industry. More than speaking English fluently. There are software engineers that are hired sometimes that may not be very fluent with English. I mean, they have good conversational skills, but they may not be like you know, the best at writing or whatever. But that doesn't matter. But what matters more is having maybe this skill. So when I end up opening a file, what happens? So all the names of the programs that I would be using, there's all these Java files. And for objects, I think it's called object file test.java. Okay? Object file test.java. So let's first work with read source.java. It's not good to use 2 screens because you're like looking at, well, why did the file not open or whatever. So there is read source.java. So one thing to immediately look at is you have to import io.java. That's the package where all the libraries exist. And we are using the Java IO API. Yes? So then we go through try catch. Try catch. So this was your intro to exception handling last time we did lab 3. Right? Do I need to cover exception handling again? At least the introduction that I gave last time? Or is everyone okay? I mean, if you want me to cover it, I can give you the Indian movie version of exception handling. If anybody's interested. If anything, it'll be entertainment. One person says, sure. And the others are like, keep your entertainment to yourself. Indian movie version. Yes. So I don't know if you guys watch Indian movies. I know you do. So the Indian movie always starts with, there are 2 types of people in this world. Right? So that's the Indian movie version. There are always 2 types of problems in this world. Well, yeah, Jonathan, of course. It can't be Hollywood. Although Bollywood makes more movies than Hollywood. So, are all of them worth watching? I don't know, but they're all on the same fucking theme. So, oh, sorry. So there are 2 types of problems. There are 2 types of problems in this world. The ones that you can recover from and the ones that you cannot. Right? Error, no recovery. And then exception, you can recover. And then there are 2 types of exceptions in this world. Or 2 types of problems that you can recover from. Problems you know about and new ones or new mistakes you will make in the future. And that becomes, when you know about, those are checked exceptions and the others are unchecked. You know how they say it's okay to make a mistake, but not the same mistake twice? Have you guys heard of that? You haven't heard of that. Why is it always me that comes up with these quotes and not you guys? You've heard of it. Of course you have. Yeah. Just not, you just don't want to talk to me. That's all. So when you follow that principle in your value system, make the same mistake. Well, when we are making the same mistake twice, or maybe more than once, then I would say the JVM, the exception handling system, is not turned on. But that's why in JVM, we are required to use try catch. So the same problem does not occur. So usage of try catch is very similar to the intelligence we have. I'm going to get in trouble for saying this, but intelligence in our mind to pivot our decision, to pivot the decisions we take. Right? So what happens in our Java programs is we put things in try catch, but in the catch block, what do? Nothing. We just sympathize with the problem. Like, Bob, you just made a mistake. And I say, yep, I did. So this is what I call sympathizing with the problem. So what I just covered was the Bollywood version or whatever it was You got to know the difference between error and exception. You got to know the difference between checked and unchecked, and why a try catch has to be used. Did I confuse anybody? Are there questions that I can help address? Please let me know. Or was this pretty clear, everyone? Yes, no will be a good answer by checking, using a little one of those buttons things in the. So for try catch, the problem occurs once and then it doesn't occur again. Well, it doesn't occur again if you actually fix it in the catch block, which we are not learned how to do that yet, but we will in the near future. So that's a good question regarding inheritance and exception handling. Let me answer that in the future. When I talk about, I want to spend an hour on exception handling. So you guys will actually learn how to, when an exception occurs, how to solve it programmatically. And so I'll cover your question at that point. Otherwise, I'll kind of, it's deeper. Yes, there is inheritance involved here as well. But right now, this is a checked exception. JVM knows about it because it's built in the API. So if I try to open a file and the file doesn't exist, it's going to throw an IO exception, which simply means that the code execution is going to stop. And I mean, the rest of the code won't execute, but it'll just go to the catch block and print that message and exit. So checked exception, when an exception handler is implemented in the API, it's going to require you to use a try-catch block. Okay? It's going to require you to use a try-catch block. So in this program, we open readsource.java. We associate a buffer, and please notice how the file and buffer work together. The file instance is passed to the constructor of the buffer. And then we say end of file is equal to false. And we say while not end of file, go ahead and read the line. If it's null, end of file is true, otherwise print the line. And when we are done with that loop, we close. This exact program will be used by you guys in Lab 5. Okay. So for the rest of this, I want to request you guys to watch this lecture, which is and I also need to spend a couple of minutes on wrapper classes, because that's another concept that's used in Lab 5. So wrapper classes are in fact really, really easy to use. So in java.lang package, in fact, have I shown you guys the Java API, like the navigation in this? I'm using the 7th edition one here, but have I shown this before, people? I'm not sure if I have, but if I have or if I haven't, whatever, I mean, here it is. We've got a list of our packages, and if you go into java.lang, you're going to find all these classes. Integer, float. These are wrapper classes. So for every primitive data type, there is a class definition. And this is just to be ORD compliant. So what happens is each of these classes have a ton of methods for doing data type conversion. Especially when you're reading data from a file, you're reading everything as a string. And so, but because you're not using string data type only in your programs, you're using int, float, etc. So then that poses a requirement for data type conversion, which is where these data types become handy for usage. So I can create an integer object, and I'll most likely ask you questions about autoboxing, which is simply taking an integer object and assigning to a primitive data type. Okay, autoboxing. So depending on the need, you look up the methods and use them with all these classes. Byte, short, all the primitive data types. I'm just going to, name them out. Integer, long, double, float. Float should be here somewhere. Yep, there it is. Boolean, wrapper classes. The reason wrapper classes exist is so we can deal with data type conversions from string to the other data types. And also have if somebody is a purist with object-oriented design, then they can use integer objects if necessary. But that's more of a lame reason for the existence. I think the real functional usage is with changing data types. So in lab 5, you can use some of the code from lab 3, which was why I went over that parser, if you recall. You guys may remember the file IO class that I had provided. So the reason to cover that was so I could have you, review my code and sorry, I'm just trying to open a version of it. Just to flash it on the screen here. And this person did a very good job of writing comments. Some of you didn't write comments. So this is what I expect you guys to use. This is more complex than what I'm asking you guys to, than what you're going to be doing in lab 5. So you can follow this structure as much as you want, so you can, so the code writing would be easier. The point is, you're given an input file. Okay? You're given an input file. You have to read this file and print out high, low, and average scores. Okay. And you have to test your code with these different number of records in the file. So I expect 5 test runs. I think we should go to Canvas site and also maybe pull up the lab description. Oh man, sorry about that. We go into assignments and we look at assignment number 5. So yeah, I'm actually providing a little bit of the design as well. I'm going to cover that. Your question about when to use wrapper classes would be clarified when you work on Lab 5. And I'll share that right away. So you will be given this text file, right? And this is what the lab description says. Lab description says, so it's object relationships and file IO. Did I not copy the whole thing? I guess I did not. I just copied the design bit. It says write a program to perform statistical analysis for a class of students. The class may have up to 40 students. There are 5 quizzes during the term. Each student is identified with a 4-digit student ID. The program is to print the student scores and calculate the statistics and print those out. You'll just print the data as shown, no sorting is needed. The input should also is to be read from the text file, and you should read the header, but ignore it, like I did in Lab 3. So here is one sample data that you can copy paste to create the number of records, right? Your class organization needs to look like this. You've got to have the model package, student and statistics. Model package will have student and statistics class. Util package will have file IO and driver will have driver. Please make sure the class names start with uppercase letter. Follow the coding conventions. All properties should be private. So what you end up doing, these are the learning objectives for the assignment. And you're given a text file. This is the actual data, and you don't have to put an extra line, right? You can just, sometimes people say, well, your task description had an extra line, so do I need to add an extra line? No, it's just poor formatting. So what you have to do is read data from a text file, compute high, low, average, and print. You can do this in main, but the point is to use object-oriented design. So you have to create a student class inside the model package that'll have student ID and 5 scores. You should have constructors, getters, headers, right? And definitely a print method. In the statistics class, you will have, and I'm deliberately changing this in the documentation. Why? because you guys copy and paste this and you never bother, some of you, never bother to change the instance variables. And then I end up saying, hey guys, you're not following coding standards. So if you copy paste from here, you know, at least it's now following the coding standards. So a question that will come up is, do I need to have getter setters for low, high, and average? And the answer is absolutely no. You just have these public methods to compute low, high, and average. And you populate the instance variables, high, low, and average. And then once you're done populating those, you'll need to write the print method. So you should add methods to print values of instance variables. So what I recommend doing, like we did in lab 3, is I would say add a print method with option. When you have the option to print, that can mean, one may mean print low scores. 2 may mean print high scores. 3, print average. And 4, print all. No getter setters are needed, you see. So this print method can be added like that. And then you have a util class. I'll also make this easy. You can just pass in the student array, give the file name, and it will read the file for you. So this should become public void. And please don't make this a static method. This should be an instance method. And there's no harm in declaring a private variable for file name and adding constructors to open the file. So you can instantiate util object with the file name. You guys know how to do this, writing constructors and all that good stuff. So for consistency, I guess I'll add that here as well. So when you read the file, I've given you the logic. And I also have given you a code snippet to step through that we did last time. Right? In lab 3. And you can use that as guidance for writing read file. So in read file, you'll be opening the file reader object. And then you'll call the readline method in a loop like we did with read source.java. So right here, you can see we open the file and we say while not end of file, read a line, right? So, and then if line is equal to null, then end of file is true, otherwise print. And all your processing of the line will go after this. Okay. You have to also, what do you do after the line is read? You have to tokenize each line using the string tokenizer object. So now the question is, how do I use the string tokenizer object? Right here. Actually, let me put this in Eclipse and show you guys. Why did I quit Eclipse? Okay. So let's go to driver and let's see and call this. And we have a string tokenizer. So this requires importing java.util, right? So what does string tokenizer do? You pass in a line, right? So rather than say this is a test, I'll pass in an actual line. So we can take something like this. So I read a line from a file. It'll obviously be stored in some variable in your case. And then when I run it, oh no. So let's do a save all and then run it again. So it takes each token and I mean, it takes each token and separates it out. Now the gentleman who asked the question about where do I use the wrapper class? Well, right here, you see. I can take one of these tokens and convert it into an integer. So if I want to convert the token 1, 2, 3, 4 to an integer, I would use something like this. So you see what I do is I take the token that's a string, I convert that to an integer, and then I print it out. You're not going to see any change in the output, but that kind of shows you oh, I see. Okay. So the person who asked the question about when do we use wrapper classes, we use it so we can take a string and convert it to an integer. That's one example or usage. So I hope that helps. Okay. So all this logic of what needs to be implemented is captured in, it's given in the plan of attack that you guys have to follow to the T to deliver. So just make sure that you test out your code I mean, follow the class structure and test with these, you know, test your code out with 5 test cases for full points. Any questions about the assignment from a technical perspective? Or are things pretty clear? Yes, no, maybe? No response. So I'm assuming no news is good news. And then now the due date. So I can probably go till the 31st at the latest for the delivery of this assignment. So it's due in 4 days. 1, 2, 3, 4, yeah, 4 days, including today 5. So that is what you have to do in assignment 5. In assignment 6, you have to do 3 things. You have to build a custom exception handler. You have to serialize the grade, and you have to create an API. And if I had to pick from the 3, or, you know, I mean, of course, I love you guys to implement all 3, and if I can cover everything, I will. But if I had to pick 3, or 1 out of the 3 to implement, I'm going to pick number 3, creating an API. So you can learn about abstract classes and interface in this course. And August 4th, 4 days will be enough to implement that. Okay. So what I'll do is I'll prioritize and cover, I mean, serialization is covered in the video lecture, but I'll cover abstract classes and interfaces first. That's really important for object-oriented programming and design. Kind of closing the loop on that is important. So that is assignment 5 and what you guys have to do. Unless there are questions, I will see you all on Wednesday.